Okay, everyone, here's a couple of comments I have on your lab reports. Of course, you should read the comments that I posted. I'm giving you very specific information, so it would be a good idea to read them before you write your second lab report. On the purpose, mostly you guys were doing fine on the purpose, but do think about the main ideas, and remember to use my notes in the lab manual for some ideas. They're telling you what the purpose is, so you can kind of do them. You want to write clear full sentences, so if you can't use the awkward wording that I use, if it doesn't quite make sense, it's going to come out awkward. You're better off using 2 or 3 sentences to describe something in simple words than to use words and phrases you don't understand. Your procedure. In general, most of you did okay, but you still need to edit out describing basic procedures. Keep in mind the audience. There are a lot of audiences we can write for, and some people want lab reports written for the audience of a student, some people want them written for the audience of a teacher evaluating if you know what you're talking about. I want you to practice using an audience of a science professional. So we want to avoid any extra information. We don't want to tell them things they don't need to know, and remember that they have valuable time, so we want to keep things brief as possible. So we don't want to use extra words. For example, the first thing that you should do is waste of words, because you didn't actually say anything that's important to the lab there. You just made the reader read 1, 2, 3, 4, 5, 6, 7, 8 words that they didn't need to worry about, or 7 words. I do encourage you to use the phrase approximately accurately. I'm going to talk about that in a bit, but it's a very useful phrase that can avoid a whole lot of words. It's a nice, efficient phrase. Also, remember that you don't actually have to write it in the order of the steps as you did them chronologically, and that will also help you to write very efficient phrases. Let me tell you what I mean. Okay, this approximately accurately, and it could be grams, so it's like approximately accurately 5 grams or approximately accurately 35 milliliters. The approximately part means it doesn't need to be exactly this number of grams, just approximately. So a lot of times when we say, obtain 3 grams, it might really be 2.8, and it might really be 3.2, and that's okay. And then the accurately part of this phrase means, but you do need to accurately know the mass of what you did use. So this does imply that you had to have taken measurements and recorded them without actually having to say, take the measurement and record it. It sort of takes care of it all in one swoop. So for instance, if I wanted to describe it without that phrase, I'd have to say something like, first record the reading of the burette initially, then dispense about 35 milliliters of liquid from the burette, and record the reading of the burette afterwards. And I can kind of skip all that and make it much more efficient by saying obtain approximately accurately 35 milliliters of liquid using a burette. So it's a very helpful phrase. Also, if you are writing a lab procedure for a student, it's nice to put it in chronological order so that they don't have to, they don't forget to do something they needed to do. But when I'm writing it for an audience of a science professional, I can be much more efficient if I don't put it in chronological order. So for instance, if I say a test tube with approximately accurately 5 grams of sodium chloride solution is heated in a hot water bath. That approximately accurately 5 grams, if I really wanted to do that and I had to figure out what steps I would need to take, I have to do some things first. I have to get a test tube and weigh it and record the weight. I have to add some solution, reweigh it, and continue back and forth until I get about 5 grams added, and then I have to record the final rate. But I don't need to say that you do those in those order. It's implied by the phrasing. Similarly, when I say, is heated in a hot water bath, the fact that if you read this sentence, you wouldn't have had the hot water bath ready doesn't matter. Someone should be pre-reading this and say, oh, before I start doing this, I need to go get I need to get a beaker and put water in it and heat it up and get a hot water bath. I can simply state it as if it's ready and available, even though chronologically I would have had to have done that first. Okay, your conclusions is basically where you need the most work, which is not a surprise. They're the hardest part to write. It's basically showing me what you are concluding and not concluding. So address the points that were in your purpose. Also, remember, this is you showing me that you are making conclusions from your data. So do that. Like, tell me your data and what you can conclude from that. I do ask you to restate your values so the reader can evaluate. In my case, in order for me to evaluate what your numbers are, I have to pull out your data sheet and go back and look at them to see what you mean, and that takes me time. In a professional, if a professional is reading it, they don't want to have to flip back a page to the other part where you told what the numbers were. So you should restate them. You don't have to restate how you got them, but just restate them. So for instance, instead of saying trial 1 was much bigger than trial 2, as a professional, that word much bigger is relative. I'm like, what do you mean by much bigger? If you show me the numbers, then I can evaluate that for myself. So it'd be better to say something like trial 1, 2.310 gram per milliliters. What's much bigger than trial 2, 2.318 grams per milliliter? In which case I'm saying, no, it's not. You know, it gives me a chance to evaluate, and it gives you a chance to correct any mistakes you're making. Also, I think we were pretty accurate. Again, well, what does pretty accurate mean? What you think is pretty accurate may not be what I think is pretty accurate. So it would be better to say something like, I think we were pretty accurate. The percent error for the trials, 1.1%, 1.4%, 3.8%, were all fairly low in my opinion. Now I know exactly what you're talking about and say, yeah, okay, I agree. That looks pretty good. When I ask for error sources, don't simply say we had error. I want what procedural things might explain your error. So not you did the calculations wrong, not you may have measured it wrong, but like what would have led to it being wrong. So the scale was, you know, was being flaky, might be an answer. I spilled something, that would be a possibility. We used a beaker which is not good at measuring, that would be an error. We noticed that there was yellow flakes in the solution, so we think that there was some contamination. That would be a procedural error. Also, don't overstate your claims. Again, I didn't put this down in this, but I want you making conclusions from your data. And so I'm looking for you to show me that you understand what your data means. So tell it to me. But when you do so, be careful not to make very strong claims. So taking one set of data or 2 trials worth of data is not enough to really make super strong conclusions on. So rather than saying, it's much safer to say something like, it appears that the density is higher because of splashing water, since it lowers the measured volume, is a much safer phrase than the density is higher because of splashing water. You're not really sure that it's higher because of splashing water. That's just a good possible reason. So again, saying it seems or my data leads me to conclude are ways of sort of softening your claims, so it's stating what your data showed me without overstating what it means. Okay, so with that, you guys can finish up your lab reports for the thermal chemistry lab, and this will be the end of lab reports for the semester.